All right, so we're just going to go over completing the square. So let's solve this equation, x squared plus 6x plus 8 equals 0 by completing the square. And this is a simpler example. So if we solve it by factoring real quick, which is how I would do this if I wasn't told to complete the square, we would get x plus 2 times x plus 4 is equal to 0. So you get x is negative 2 and negative 4. So now we're going to show how we could get the same answer by completing the square. And if you ever used a quadratic formula, that was derived by taking ax squared plus bx plus c equals 0 and completing the square. So if you get really good at completing the square, try to solve this for x using completing the square, and you'll see that x is going to equal the quadratic formula. So that's a fun exercise that we would do if we were all in class, and we'll try to do it regardless, maybe one day in the afternoon. All right, so that's another way to solve this. You can use quadratic formula. A third way would be complete the square. So here's how it works. First thing you want to do is make sure that your coefficient is 1. So if it's not, if this was a 2 or a 3, you would divide everything by 2 or 3. All right, so the coefficient is 1, so we're good. Then we want to get all the x's on one side. So I'm going to subtract x on both sides. Sorry, check that. Subtract 8 on both sides. All right. Now we're going to complete the square. So what the heck does that mean? What does it mean to complete the square? All right. Well, if we were to draw a geometric representation of this, all right, so if I drew a square that had length x, all right, this area would be x squared. And then if I drew a rectangle that had length 1 by x, so I do 3 of them, all right, so 1, 1, 1 by x, and then this would be a 1 by x, 1 by x, 1 by x, okay? This would represent 3x in area, and this would represent 3x in area. So what I have here is a square that's not complete. All right? It kind of looks like a square, but it's missing this chunk right here. So we have to complete the square. So the number that you use to complete the square, and what it means is we want to make this a perfect square trinomial, something that could be factored to just like x plus or minus something squared equals something else. That's what it means to complete the square. Now, if we look at this geometrically, we could see that if we just added 9 1 by 1 squares, right, so we added 9, then that would make this a perfect square, where this side was x plus 3 in length, all right, and same thing with the other side. It was also x plus 3 in length. So if you get x plus 3 times x plus 3, or x plus 3 squared, that's going to equal x squared plus 6x plus 9. All right, and all we do is factor. Now, we did just add that to the left side, so we also have to add it to the right side. So we get 1 on the other side. Now, I don't suggest that you draw this square every time and think of it that way. There's an easy rule to get this number right here. And the rule is you take half of b and then square it. So 6 divided by 2 is 3, squared is 9. So to complete the square, once you get down to this point where you have x squared plus something times x, you're going to take that number in front of x, cut it in half, square, and add it to both sides. All right, because then you get this equation, which since this is factored, now you could just take the square root of both sides. So you get x plus 3 equals positive or negative 1, because you're squaring something and getting 1, so it could be negative or positive 1. Then we get two separate equations, which is kind of reminds us of the quadratic formula, because that's all the quadratic formula is. It's completing the square with this, and then using that formula for all quadratics. Then you subtract 3 on both sides, and you get negative 2. And you subtract 3 on both sides, and you get negative 4. And that's the same answer that we got when we factored, which makes sense because it's the same equation. All right, so you don't have to do this unless it tells you to, but it's a good exercise to do because there will be times down the road where maybe you're not solving an equation, but it's good to know how to complete the square, specifically when you're doing things like circle equations or ellipses or hyperbola, things that you'll do in pre-calculus or sometimes in algebra 2. All right, so you want to know that rule, which is take half of b and square it. All right, so I'll make another video where I go over a more complicated example. That's the gist of it. Put it in standard form, step 1. Step 2, get the x's alone. Step 3, add half of b squared to both sides. Step 4, factor. Step 5, solve that more simple equation by taking the square root and isolating x. All right, that's complete the square.